Good day everyone and welcome to this brand new video. Today I'll be talking on Thevenin's theorem and how to simplify complex circuits using Thevenin's theorem. So let's get into it. The problem that Thevenin was trying to solve is, look at this circuit for example. Let's say we only care about this load, this RL. Do we need to analyze the entire circuit every time in order for us to have parameters from this part of the circuit? No. That is going to be really cumbersome. So what Thevenin is trying to solve is that it's bringing an alternate way in which we can just replace this entire circuit, this entire part of the circuit, with just a voltage source in series with an equivalent resistance in series with this load. And this is how the equivalent circuit is going to be. This is our load. We're going to simplify this entire circuit to just be one voltage source in series with one equivalent resistor known as the Thevenin in series with the load. So we have this voltage source also known as a Thevenin and the equivalent resistance known as the Thevenin in series with the load. And this way we can calculate whatever we want to calculate from this load, the current, the voltage, and whatever we need to calculate easily without going the stress of calculating everything from here. So we can just replace the entire network seen by the load with an equivalent circuit of Thevenin and Thevenin. So what is Thevenin's theorem? Definition: any linear two-terminal circuit can be replaced by an equivalent voltage source Vth in series with an equivalent resistance Rth. Looking at this complex circuit, after applying Thevenin's theorem, we are going to have a circuit like this: Thevenin and R in series with Thevenin. Thevenin is the open circuit voltage seen between terminals A and B, while Thevenin is the equivalent resistance seen looking into the circuit from terminals A and B, with all independent sources deactivated. Terminals A and B with all independent sources deactivated. Similarly, like what we do in superposition theorem, if you haven't watched the video on superposition, you can check it out on our page. You will realize that when we want to analyze, we have to turn off this voltage source. If we want to turn off this voltage source, what we do is we take it off and we replace it with a short circuit. Then we can calculate the equivalent Thevenin resistance just from looking from the points A and B. How to find the Thevenin equivalent? First thing, we remove the load from the circuit. Second, we find the open circuit voltage. The open circuit voltage seen from terminal A and B is our Thevenin equivalent voltage. Then we find the Thevenin resistance by we take off the voltage source, we short circuit the voltage source, then we calculate the equivalent resistance of the circuit, that is going to be our Thevenin. Then reconnect the load to the Thevenin equivalent circuit. So the Thevenin equivalent circuit is this voltage source, which is a Thevenin in series with the Thevenin. We are going to connect the load now seen from terminal A and B, and that is where we can simplify this load as easy as that. There are two key values, which is Thevenin voltage and Thevenin resistance. Like I earlier on said, Thevenin voltage is just the open circuit voltage, and Thevenin resistance is the equivalent resistance of the circuit after all independent sources have been removed. Thank you very much for watching this video. Stay tuned and watch part 2 of this video, because we are going to solve an example using Thevenin's theorem in the part 2. Thank you very much for watching.